The Magbot is our solution to microplastics in the ocean. William, Tyler, Parker, Katie, and Zoe created this, and our teacher's name is Mr. Barry. So we're tackling the United Nations goal number 14, life below the water. Whoa! There are 24.4 trillion pieces of microplastic in the upper ocean with a total weight of 578,000 tons.
What are microplastics and where do they come from? Microplastics are small pieces of plastic that are less than 5 millimeters long and are harmful to our environment. These consist of synthetic textiles, tires, city dust, road markings, and other things, which is like coming from our clothes, our cars, and from our cities. Now, the effects of microplastics is that a lot of fish actually have microplastics found in their dorsal muscles, which affects their swimming. Plastic doesn't biodegrade and disintegrates into smaller pieces, which is really dangerous for our environment. Microplastics are really large, can be really large, and carry toxins and heavy metals. Microplastics are also eaten by fish and other aquatic life, which can lead to their own death.
Okay, so our solution to this microplastic problem is Magbot. Magbot is a microrobot that navigates the ocean independently and utilizes a magnetic solution to collect microplastics floating in the water column. The Magbot works by a powerful electromagnet with a body that has a rudder and propeller to control the movement of the nanobot. The magnetic nanoparticles are dumped into the ocean, and so is the Magbot. Then the Magbot pulls all the electromagnetic nanoparticles that bonded with the microplastics on the magnet out of the water and onto the boat.
Okay, so the actual process of microplastic conversion that we have laid out is broken down into 5 steps. The first being releasing the magnetic solution into a section of the ocean, and then the Magbot will then follow that solution and collect the microplastics. After, the microplastics and the Magbot will be taken back out of the ocean, and then another piece of nanotechnology called nanocoils will break down those microplastics into carbon dioxide and water.
Our step 1 is to release spions into the ocean. Spions are specially coated iron oxide nanoparticles, which are smaller than microplastics, making them ideal to bond with plastics and form conglomerates that are then easily collected with magnets. The advantages of this are that they're adaptable to many environments, they're not toxic so they aren't harmful to the environment, and they're efficient because they can differentiate between plastic and inorganic sediment. After the spions bond with the microplastics, the Magbot collects them with a magnet. And then step 3, we bring the Magbot back onto the boat. For step 4, we use nanocoils, which when heated to 160 Celsius create free radicals, breaking down microplastics into smaller pieces that are then converted into carbon dioxide and water.
The total percentage of microplastics converted by the nanocoils into CO2 and water would be 50% for 8 hours and then 100% for 16 hours.